Hello, welcome back. This is skill number 2 in MA 106. We're in geometry land here for the first 6 skills, so obviously in skill number 2, we're still in geometry land. No big surprises there. What we're going to talk about in this skill is polygons, which are shapes, right? Specific kinds of shapes. In this case, polygon is a two-dimensional shape that's formed by connected straight line segments, right? So that means 2 dimensions, right? So not 3D. We'll talk about volume in 3D in a little bit. So 2-dimensional shapes, you have sort of a length and a width, and all the segments are straight line segments. So there's no curves here. This is a little bit in contrast to the angles in skill number 1, which obviously if you have an angle, you're sort of getting a curve. We're going to sort of tie all this stuff together a little bit later. Common polygons, you might think obviously sort of squares, rectangles, triangles, right? So in some sense, different polygons are kind of named based on how many sides they have. Pentagons, hexagons, octagons, right? Penta sort of means 5, would be 5 sides. Hexagon would be 6 sides. Octagon, right, like octopus, would be 8 sides, like a stop sign. What we're going to look at here initially are 2 different sort of properties of polygons, which is their perimeter and also their area. So it's 2 different measurements for polygons. Perimeter, we sort of have a little bit of a visual here. Perimeter is the distance traveled around the edge of a figure. So if, for example, I have this rectangle, right, 4 centimeters by 2 centimeters, the perimeter would be essentially, what would the distance covered be if you essentially just like walked around the edge of this all the way back to where you started. And so if you're kind of doing this in centimeters, you can kind of count your way around. This sort of numbering here is trying to help sort of illustrate that, right? So this is 4 across and then sort of 2 down. So this would be kind of 1, 2, 3, 4 centimeters across, right? 5 and 6 to get down, 7, 8, 9, 10 to get back across, and then like 11 and 12 to sort of wrap it up. Perimeter, for the most part, you can essentially just add up the side lengths. You don't have to individually count every centimeter or inch or foot like we're kind of doing here. For the most part, we'll just sort of be adding them up. Area, what we're measuring here is 2-dimensional space. So not just the distance around the figure, but actually how much 2-dimensional space does it take up. So you think of area a lot of times in the simplest sense as sort of a length times width, or sort of a base times height. That's what we're going to end up here. Each of these squares, right? Think of this as like, what's the distance around a room versus like how much carpet would you need to put down to cover the floor, right? So the distance around the room is your perimeter. How much carpet it would take to sort of cover the floor covers the full area are going to be 2 different measurements, although they are related. If you're trying to sort of count each of these squares, then what you get, if you think of this as sort of my units here, would be 1, what we call square centimeter. So this is literally 1 centimeter times 1 centimeter, right? So you get these square units that take up space. So these 1 by 1 blocks. And so if you start to sort of fill this in, right, you have sort of 1, 2, 3, 4 blocks on the top row, and then sort of 5, 6, 7, 8 blocks, I guess 5, 6, 7, 8 blocks on the bottom. So this is obviously going to be sort of 8 total blocks, 8 centimeters squared. Obviously, you're probably yelling at your computer right now saying like, just do 4 times 2. 4 times 2 is the area, 4 times 2 is 8. And yes, that is true. That's exactly true. So we'll go over a few different formulas here for a couple of our sort of standard shapes. We scroll this up. We're going to focus on 4 for now, and then we'll also sort of look at combinations of these shapes together. So most common, obviously, sort of squares and rectangles. Squares are sort of special versions of rectangles, right? A square, you have 4 sides, and all 4 of the sides are the same length. You also have these, what we sort of say, right angles, square corners, right? 90-degree angles. So everything here sort of fits together just so. Your perimeter would just be, well, whatever your side length is. If you add all 4 of the sides up, they're all the same length, so it would just be 4 times whatever that length is. And then your area, in theory, right, are sort of generic base times height, or like length times width, right? In this case would be whatever the side value is times itself, because they're all the same. So you'd have sort of the side length squared. Rectangle's a little bit more general, right? The idea here is you have sort of matched pairs of sides. You have sort of a length and a width, but they're not necessarily the same values, right? So you can get sort of, you know, this is kind of a long, short one, sort of a short and wide one. You could get tall, skinny ones. You could get them where they're even, and then you have a square again. Your area value, right, is our classic length times width, right? You have the 2 different values. Your perimeter would be, right, adding up all the side lengths. What would happen is you would get 2 of each kind, right? 2 of the length and then 2 of the width. So you could think of it as 2 times L plus 2 times W, or this kind of simplified version, 2 times whatever your sort of L plus W is. Either one of those works. I'll sort of also put this in as sort of a backup, right? Perimeter would just be 2 times length plus 2 times W. Either one of those works, or you just say L plus W plus L plus W, right? In sort of the most basic sense. More specialized figures, so a triangle. In some sense, if you actually lose a side, so now you're down from 4 to 3 sides, triangle, like tricycle, right, means 3. And so what happens here is you get, in theory, 3 unique side lengths. They're not totally listed here. Your perimeter is just going to be the very basic add up all of the side lengths formula. It's almost not even really a formula to write. It would just be sort of side 1 plus side 2 plus side 3, and you'd be good to go. The more particular formula here is the area formula. A triangle, in some sense, takes up you could think of it as taking up sort of 1/2 of the area of what a rectangle would take up. That was sort of similarly sized. If you kind of draw in a rectangle, you could essentially make another version of this triangle with the sort of empty space. So rather than having what we would think of as sort of the base times height or the length times width for the area here, you actually have 1/2 base times height. And what's a little bit tricky with your triangle is you just have to sort of watch that height value, right? There's a little bit of a perspective thing that happens. So if this is your sort of base along the bottom, your height is going straight from that up to the topmost corner. So that's not necessarily going to be one of your edges. You might have to sort of draw in this sort of extra line that kind of comes down and sort of runs right into the base. Again, you want it to sort of hit at a 90-degree angle, this sort of perfectly square corner, to get what you're after. So 1/2 base times height, where you're sort of setting up the base and the height. You know, if you took this triangle and you sort of flipped it around, or sort of flipped it by, 90 degrees going one way or the other, obviously you can get a slightly different perspective. You might need to sort of turn your head a little bit sometimes when you're trying to kind of identify what's the base, what's the height, what am I doing. It's all about being a little bit, being able to adjust a little bit. The trapezoid is sort of the 4th one we're going to look at as sort of a go-to polygon, a go-to figure. It's kind of like combining a triangle and a rectangle together, right? It sort of is rectangle-ish, but it sort of has some of these tilted sides that the triangle has, right? So it's not totally square corners. It's sort of parallel sides on what would be sort of our top and our bottom. This is what we're sort of labeling here as kind of base 1 and base 2. You could sort of, again, think of it as sort of the top and the bottom. And then as far as measurement values, where you have the sort of tilted sides, we're not going to use those for the area. Again, our sort of just basic perimeter is just going to be add up the side lengths, 1, 2, 3, 4, whatever those lengths are. But the diagonal lengths, right, the sort of slanted edges, you're not going to use for your area. The area is exclusively from the two base values and the height value. And it has a similar formula to what you use for triangles. Rather than being 1/2 base times height, there are in some sense two different base values, base 1 and base 2. So you actually add those two together, base 1 plus base 2 in parentheses, and then you do 1/2 times that value times the height. So it's 1/2 times the sum of the two base values, and then you multiply that value by the height. So getting those four figures is sort of what we're going to start with. I'm going to run in the next video a couple examples, just sort of doing this with a few figures, nothing super wild. And then later on we'll actually do some combinations. So square, rectangle, triangle, trapezoid, perimeters, and areas.